A trigonometry and geometry app. The power of Python for building math applications.
Hi everyone, welcome back. And today I'm going to show you an application for mathematics. It's a simple one. Essentially, it's good for math students and math enthusiasts or hobbyists. Basically, I wanted to show you how you could leverage Python, the power of Python essentially, to build an application that can help you with your studies or basically just about tackling any math issues or um, math equations that can help facilitate things for you. So, one thing that I do want to emphasize here is that this is actually a really great example of modularity. So, for instance, in this app, we have one part that is trigonometry, another part that is contained in another file, which is two-dimensional, and the other one is three-dimensional calculation, three-dimensional shapes. So, modularity is good here because what it does is that it allows you to keep growing the app and modifying it to your needs. So you could add a lot more, for instance, trigonometry or 2D shapes or 3D shapes. So I hope that you like this episode, and I'm gonna jump right into it. I will start with the finished product, show you what it's like, and as always, I have the links in my GitHub page. So yeah, let's jump right into it.
All right, so as you can see here, there's only a couple of files, and I'll just start by running it. By the way, just as you could see, the folder is on my desktop. So the folder is actually the project name. And let's get this running. And this is the application. So we have trigonometry, we have two-dimensional shapes as well as three-dimensional shapes. So for trigonometry, we have a unit circle. It is interactive, so the graphical user interface is interactive, very nice. We have inverse functions, so we could just go ahead and change that, and we get arcsin, arccos, and arctan. We have some trigonomic identities as well, and we have right triangles, so we could put like 90 degrees, and there we go. It is quite interactive. It gives us some examples as well that we can use. Let's go to the 2D shapes. So the 2D shapes is a drop-down function, and we have added. So this is the 2D, which is a file on its own in our program, and I'll show you it's part of the being modular, as well as the trigonometry. So this is why this script is modular. We have a file for trigonometry, a file for 2D shapes, and a file for 3D. So square, obviously, we'll just put like, there we go. Um, and let's go for something a little more complex. And there we go. So in this case, we have a scaling triangle. Um, we have other shapes. Here's a rhombus. And we also have 3D shapes. So basically a sphere, give it a radius, and it's going to provide you with the volume, surface area, etc., as well as provide you with um, you have the formula at the bottom. So some additional examples. Um, well, these are the inputs, sorry, inputs, so examples for inputs. And for cylinders, so you have the information as well on the design. For the 3D shapes, I've noticed that we didn't have a calculation. So now we do have one. And I wanted to show you how quickly it was to adapt this within the code. So what I did is I went to my NLP, the NLP here, and basically you can use any Gen AI type NLP. Um, and in this one, I have advised, if I go back, I have advised that we need the formulas to be displayed um, to the 3D shapes. And that is a bit right here. So do we have the formulas for the 3D shapes in the Shapes 3D module? Shapes 3D module right there. And it advised that we don't. Would I like to have it added in? So yes, I advise that we need to display for the students so they don't cry. Um, and it actually is kind of playing along with my joke here, with my humor. So it advised that it's going to provide the code, and that will definitely reduce confusion and tears. So that's always nice to see in NLPs. Um, what I did is I simply copied the new code. So it provided the new code. I asked it, and this is a trick that you can always use, ask it to provide you the new code from scratch, which includes all the details that are needed from the previous code. So basically, just to provide the new updated code from scratch, and you will just copy and paste that um, in the module that is where the code is needed. So in this case, it was three-dimensional shapes, so I integrated it into the shapes 3D module.py. And we have now the formulas here as well. In the 2D, we have it. The formulas are already included, so we have like the triangle area, which is area equals half of the base and height, base times height, so half base and height, which then provides us with the right information. So let's go to, for instance, triangle, and we get the base, and then let's put a height, which will be a bit higher. So there we go, a perfect triangle, two right angles there. Um, so yeah, uh, and in our 3D shapes, it's just included at the top here. It's a great app. Again, the modularity here comes from the fact that you could add to trigonometry. So if we go to our trig file here, and we can ask the NLP at the bottom, let me just pull that out here a bit. So we can ask, are there um, are there any additional trig any additional trig functions that we can add? It will probably give us quite a list, and you can choose those and just have them integrated in your trigonometry module. So here's a whole bunch of them. um, cosecant, secant, cotangent, graphs of all trig functions, law of sines, sum of difference formulas, radians, hyperbolic, trigonometric functions. So you could definitely go ahead and introduce this. Um, any additional 2D shapes? And we're going to just precise that it's 2D geometric shapes. We'll probably get a lot more here than the trigs. There's going to be a whole list of them, and it's the same principle for the 3D one. And the change that you want, essentially, where you would like this to be added would be in the shapes 2D underscore module dot pi for the 2D shapes. It would be for 3D shapes, you'll be under the shapes 3D underscore module dot pi. And the same for trigonometry. That one would be in the trigonometry underscore module dot pi. So you could really enhance this, make it your own. I've provided you with the code that you can start with, and I have also included in the GitHub. I have included the optimal um, the optimal natural language that I've started with. So let me bring you there. So here we go. We have This is the optimal structure of the code. So you could just really adapt anything that you'd like here to get going from scratch. You don't necessarily need to just go ahead and use uh, the codes that I've posted. You could really just um, see what you could do, what you could build from scratch, and and just go from there. Now, I've also included something that you might be interested in, and that is to create an executable icon. Let me show you what that is. Essentially, you don't need to run your apps all the time from the IDE. Um, in this case, you could just, instead of going through Visual Studio, you can have the app right on your desktop. Let's just close that. So here we go. Just double click and the app is ready and running. There we go. So yeah, everything that you would need is I've put the links in the GitHub page, and go ahead, play with it, make it your own, and just see how far you could drive this. Um, Build it as needed, enhance it, and just enjoy the journey. I hope you enjoyed this episode. Thanks for watching, and I'll see you next time. Bye for now.